If A cross B is 0, that is if the angle between the two vectors are 0, that means the two vectors are parallel. Cross product of two vectors is denoted by vector A cross vector B, and it is defined as A cross B is equal to AB sin theta dot n cap. Vector A cross vector B is a vector, and when you take the magnitude, it's a scalar quantity that denotes the area of the parallelogram. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. In this section, we are going to study about the vector product of two vectors. So in our previous session, we have studied what is dot product and the applications of dot product. Now here, we are going to study vector product. The vector product of two vectors is also known as the cross product of two vectors. So, vector product of two non-zero vectors. We need to take two non-zero vectors where vector A and vector B is denoted by, that is a cross product of two vectors is denoted by vector A cross vector B, and it is defined as A cross B is equal to AB sin theta dot n cap or into n cap. A and B represents the magnitude or the length of vector A and vector B. Sin theta, that is theta is the angle between them, and n cap is the unit vector in the direction of perpendicular to the cross product of vector. So here I have taken a geometrical figure of vector product. If this is vector A and vector B, theta is the angle between them, then the perpendicular line denotes the cross product of two vectors, and here you have the n cap, that is the unit vector perpendicular to the direction of A cross B. Thus, A cross B of vectors is given by AB sin theta into n cap, where theta is the angle between the two vectors and the condition is that theta should lie between 0 to pi. And n cap is the unit vector perpendicular to the plane containing the two vectors A and B. Now, what are the observations here? So, we know that A cross B is equal to AB sin theta dot n cap. So, magnitude of vector A, magnitude of vector B can also simply written as A and B. So, now A cross B is a vector, that means it contains the components of x, y, z axis I, j, k in the form of AI plus bj plus ck, or we can say x1i plus x2j plus x3k. Thus, A cross B is a vector quantity. It is clearly a vector quantity because you can see the vector perpendicular to the plane is nothing but the product of two vectors A and B. Therefore, A cross B is a vector. And when I apply the magnitude, if I need the length of A cross B, then you should apply the magnitude for all this. And what is magnitude of n cap? Since it is a unit vector, its value is 1. So therefore, the magnitude of A cross B is just AB sin theta. And thus we can define theta, that is the angle between vector A and vector B in cross product, such that sin theta is magnitude of A cross B divided by magnitude of A and magnitude of B. Cos theta is A dot B by AB, and here sin theta is also A cross B divided by A and B. Next, now we know that sin theta is A cross B divided by A and B. Now if theta is equal to 0 or theta is equal to pi, we know that sin 0 is also 0, sin any pi is also 0. So therefore, A cross B will be 0. If A cross B is 0, that is if the angle between the two vectors are 0, that means the two vectors are parallel. Thus, we can conclude if two vectors are parallel, their cross product of the vectors are 0. And similarly, if two vectors are perpendicular, we can say the dot product of the vectors are 0. If two vectors are parallel, their cross product are 0. So, again, in particular, vector A cross vector A is again, it's a 0 vector, or vector A cross minus vector A is again 0, because A coincides with A and minus A is just opposite direction to vector A, and hence the angle between these two vectors will be equal to pi, and A cross A is 0. So therefore for theta and 0, vector product is 0. Therefore A cross A is 0 and A cross minus A is also 0. Now suppose, what is if theta is equal to pi by 2? What happens if theta is equal to pi by 2? If theta is equal to pi by 2, then we know that sin theta value is 1. Just we can say that is A cross B is just equal to A into B, because the value of sin theta, sin pi by 2 is 1. Hence, if theta is equal to 90 degree, the cross product is A into B. Now what happens for the component vectors I, j, k? Now, since A cross A is 0, we can also say I cross I as well as j cross j, k cross k is equal to 0. These are all equal to 0 here, because the angle between them is 0. Hence, the cross product becomes 0 when they coincide or when they are parallel. Similarly, we can see if these are the vectors I, j and k. So, if I cross j is equal to k, and this is what happens. We can write I cross j is equal to k, j cross k is equal to I, and k cross I is equal to j. So these are the cross product of vector components I, j, k. Similarly, if you take j cross I, then it is minus k. When you change the I cross j, the direction of the vectors, I cross j is k, but j cross I is minus k. Similarly, j cross k is I, k cross j is minus I. K cross I is j and I cross k is equal to minus I. Also, we need to know that vector A cross B is nothing but minus vector B cross vector A, or when you apply the magnitude to this vector, the magnitude of vector A cross B can also be written as minus of vector B cross vector A. So also we should know that, so A cross B is nothing but AB sin theta into n cap. A cross B can also be written as B cross A, but B cross A is nothing but the negative of A cross B. Their magnitude will be same, that is magnitude of B cross A is same as magnitude of A cross B, but the vector form is if B cross A is equal to the minus of A cross B. Now let's see the component form of a vector product. So the component form of vector product is just the determinant of the values I, j, k, and suppose vector A is A1i, A2j, A3k, then the components A1, A2, A3 must be written in the second row, and vector B, B1i, B2j, B3k, then the components of vector B must be written in the third row. So this is how we will evaluate the cross product of any two vectors. Thus, A cross B is the determinant of I, j, k, A component and B component. So we know how to evaluate the value of determinant from the chapter determinant. So applying the same concept, we can find the value of the vector product of two components. Next, geometrical application of vector product. Suppose if vector A and vector B are the adjacent side of any triangle, then the area of the triangle can be calculated from the cross product using the formula half of magnitude of A cross B. So we can find the value of A cross B using the determinant method. It is purely vector, and when you apply the magnitude, that is the distance, it's a scalar quantity, and half of the magnitude of A cross B gives you the area of triangle. Again, the second one is that if vector A and vector B are any two sides of a parallelogram, then the area of the parallelogram is given by magnitude of vector A cross vector B. Vector A cross vector B is a vector, and when you take the magnitude, it's a scalar quantity that denotes the area of the parallelogram. Next, find magnitude of A cross B if vector A is equal to 2i plus j plus 3k, and vector b is equal to 3i plus 5j minus 2k. So here we know that A cross B is I, j, k. Second row, we need to write the components of vector A, that is 2, 1, 3. And components of vector B are 3, 5, minus 2. Let us expand the value of the determinant. It is I into, so minus 2, minus 15. Next, we have minus j. So delete the column, delete the row. 2 into minus 2, minus 4, minus 3 3s are 9, plus k. So 2 5s are 10, minus 3. So we get it as minus 79. Minus 4 minus 9 is minus 13. So we get plus 13j. And here we have 7k. Now this is our vector A cross B. Now let's take magnitude of vector A cross B. It is square root of the sum of squares of the component, minus 17 whole square plus 13 square plus 7 square. This is equal to square root of 507. So that can also be written as 13 root 3. Next, find lambda and mu if 2i plus 6j plus 27k cross I plus lambda j minus mu k is a zero vector or a null vector. So first, let us take the cross product of these two vectors, that is I, j, k. My first vector is 2, 6, 27. Next, 1 lambda minus mu. So this is equal to the null vector. So now let us evaluate this. I into minus 6 mu minus 27 lambda minus j into, so again it is minus 2 mu minus 27 plus k 2 lambda minus 6 is equal to null vector. Let me write null vector in the component form, that is 0i plus 0j plus 0k. So now equate I component to I component, j component to j component, and k component to k component. So since two vectors are equal, we can equate the corresponding component. Thus we get minus 6 mu minus 27 lambda is equal to 0, minus 2 mu minus 27 is equal to 0, and 2 lambda minus 6 is equal to 0. So leave the first equation because it contains both the constant. Let us solve the second and third. We can write here 2 mu is equal to 27, or we can write mu is equal to 27 divided by 2. So this is the value of mu, and here we have 2 lambda is equal to 6 or lambda is equal to 3. So this is the value. So we have minus here, so we can write minus 27 divided by 2. So this is the value of mu and lambda. Next, given that vector A dot vector B is equal to 0 and vector A cross vector B is equal to 0, what can you conclude about the vectors vector A and vector B? So if dot product of two vectors are 0, then this implies vector A is perpendicular to vector B, or we can say either vector A is 0 or vector B is null vector, so 0 vector. So similarly, vector A cross vector B is equal to 0 here. This implies vector A is parallel to vector B. So this also implies either vector A is null vector or vector B is null vector. But vector A perpendicular to vector B and vector A parallel to vector B never holds simultaneously. So it is never possible at the same time. Either vector A must be parallel to vector B or vector A must be perpendicular to vector B. It can never happen at the same time. So thus we can include vector A is equal to vector 0 or vector B is equal to vector 0. So this can never happen. So the only thing is either vector A must be equal to 0 or vector B must be equal to 0. Then only A dot B becomes 0 and A cross B is also null vector. Next, let the vector A and vector B such that magnitude of vector A is 3, magnitude of vector B is root 2 by 3. Then A cross B is a unit vector. Find the angle between vector A and vector B. So whenever cross product is given, we know the angle between the two vectors is given by sin theta is equal to magnitude of vector A cross vector B divided by magnitude of vector A, magnitude of vector B. Now since A cross B is a unit vector, magnitude of unit vector is 1 and here it is 3 and this is root 2 divided by 3. So 3 get cancelled, the value is 1 by root 2. So there this implies theta is equal to sin inverse of 1 divided by root 2. So for what values of sine it is 1 by root 2. So it is pi by 4. So therefore we can conclude the value is pi by 4 or the angle between the two vectors vector A and vector B is pi by 4 or 45 degree. So we will see a few more problems in the next session. Until then, keep watching, keep learning, keep exploring. Thank you.